Hey everybody, meteorologist Liz McGiffin here, and today I want to talk to you about temperature and density and how that plays a role in our weather. So here's what you're going to need for this experiment. It does have the potential to be messy, so I recommend grabbing something like a pie pan or a casserole dish that just in case we spill some water, it'll be able to keep it all in. Now ideally, we aren't going to be spilling anything, but just so you're ready to go. Also, you're going to need some hot water, some cold water, and some cups to put all this water in. So I'd recommend grabbing 4 clear glass cups if you have them, or if you're like me, maybe you don't have the see-through glass cups, clear plastic ones will work just fine for this experiment too. We may just have to alter the temperature here in a little bit if you're using plastic instead of glass. So the big thing that you're gonna need for this so we can tell the temperature of the water apart is not only your 2 cups of ice cold water, literally just melted the last couple of ice cubes in here a minute ago, but so we can tell that apart, I want you to add some food coloring. So I'm gonna stick to the traditional blue for cold water and red for hot water, but as long as you have 2 different colors, we're gonna be able to accomplish what we need to with this experiment. So go ahead, and once your cups are filled all the way up to the top with water, add some food coloring, just about out of the blue food coloring here, but I think that'll be enough to work. Maybe give that a little stir so we have our blue ready to go in both cups. You're only going to need these one at a time as well. So if you only have 2 clear cups, that'll work for us too. So you can put one of these to the side for now. And in another cup, I need you to carefully pour some hot water or some warm water. So if you've already warmed up your electric kettle like I did to get your warm water ready to go, then that'll be fine. Do want to give you the warning though, that if you are going to be using hot water, glassware is going to work better, because if you're like me, maybe you added the water too hot directly into the cup, it might literally melt it. So if you have a plastic container, it's still going to work. Just make sure that you have more of a warm water to the touch as opposed to hot. So I brought it to a boil and then let it sit for a while. Next thing you're going to do, kind of like what we did with the cold water, fill the cup all the way up. This one's just about full. We're going to put some more in this one. I also like to kind of put it in a different container so it has time to cool down just a little bit. You still want to make sure you have a big temperature contrast with this. Fill it up all the way to the top or just about there. And then, so we can tell our warm water apart from our cold water here in a minute, I want you to add a couple drops of red food coloring, or just some color that's different than what you previously used for your other cup. Make sure I wipe off my spoon so we don't get any of the blue in there. Give it a nice little stir. And then one more thing that you're going to need for this experiment is going to be something that can work as a divider between these 2 cups, because I'm going to put this guy to the side for now. What we're literally about to do is flip one of the cups on top of the other. So let's start with our blue cup on the bottom and our red cup on the top. The way that we're going to accomplish this, we'll push this to the other side so you can see it here in a second. The way that we're going to accomplish this is you need some sort of divider. So if you have maybe a piece of plastic that completely covers the mouth of the cup, that'll work. If you have a note card or even the cardboard part of a notebook, you take that off. As long as it completely covers the mouth of the cup, it's going to work fine. And then for this experiment, I'm just going to use a see-through Ziploc bag. The big thing is that it's going to completely cover the mouth of the cup. And also with this, I should have mentioned this off the top, the cups need to be exactly the same size so they fit perfectly on top of one another. So now comes the tricky part. We need to make sure the mouth of this cup is completely covered. And now we're going to take our cup of hot water and put it on top of our cup of cold water. You want to make sure when you flip it upside down, you don't have water coming out. Also put it right on top. It should perfectly fit on top of the other one. If you're like me, maybe it leaks just a little bit, so that's why we have this Tupperware ready to go. And slowly and carefully remove the plastic or whatever your barrier is and watch and see what happens. This part is a little difficult because you need to be very careful with it and make sure that you don't spill too much in the process. That's the goal, at least. Oops. Keep it nice and overlapped. Eventually we'll get this out. Okay. Ta-da! And now, look what happens. I'm gonna grab a roll of paper towels, which It's a good thing to have on hand in case you need cleanup so you can see more of the contrast of what's going on. You'll notice, make sure it's lined up too, not a whole lot happened. Normally when you combine the water, that all get mixed up, right? But what's happening with this is that cold water, or in our atmosphere, colder air, is more dense. So it's almost like it's more heavy and it naturally sinks to the bottom. Versus hot water, or in our atmosphere, hot air, which acts like a fluid, it rises right back up to the top. So these cups, they're actually gonna stay exactly where they are with all the blue on the bottom and the red on top, and you can see almost right in the middle where they overlap, maybe just a little bit of purple forming. So now that we know what happens if we have the hot on top and the cold on bottom, let's figure out if we reverse this. So do exactly what you did with that last round of cups. We already have our blue, so our cold water ready to go. Now just fill up your other cup with your hot water. And just like we did last time, it's gonna be important so we can see the contrast between the hot and the cold by adding something like food coloring here in a minute too. So again, you can use whatever colors you like. I just kind of stuck to the traditional blue for cold, red for hot. And then add just a few drops in there. Maybe the more that you add with the food coloring, the more contrast you'll be able to see. So that part makes it fun, but even if you add just a few drops, you'll be good too. Okay, now that we have our hot and our cold ready to go, let's figure out if we just flip the process around. Again, here comes the tricky part. Get your bag, your plastic, your note card, whatever you need ready to go. And this time, we're gonna cover up the mouth of the blue, so our cold water, which represents cold air, and flip it right on top of the red. We were successful the first time. Let's see if I can do it a second. Okay, flip this guy over. Already looking good. It's not leaking out of the baggie just yet, but we have the container ready to go just in case. Our barrier's good. Okay, just a little bit of drippage. Make sure that you have everything all nice and lined up, and watch and see if we can get the same effect as like we did with the cold on top and the warm on bottom. Instantly, you're probably going to notice a bit of a change. You're going to start to see that the cold water, which represents the cold air, sinking down to the bottom. And the reason for that? Well, it's exactly the same reason that we have them divided in this container. The cold air, or in this case, our cold water, it's more dense than the warmer air, so it pushes its way down to the bottom. As a result, our less dense air, or our less dense water in the experiment, it gets forced all the way up to the top. So you're gonna notice this nice even purple all the way through because we have a mixing of what's going on. Now here's how this also relates to our atmosphere. This guy over here, where we've got the warm air comfortably sitting on top, cold air comfortably sitting on the bottom, that's what we call a stable atmosphere. All the atoms are very happy where they are. Versus as soon as you get something like, say, a cold front to move through, that's when you literally have cold air that dives underneath warm air, pushing it up toward the surface. And that's the upward motion that we see in our atmosphere, from the cold air on the surface, the warm air rising above, that creates instability. And the instability, when it gets paired with moisture, can create thunderstorms before the cold air at the surface really starts to cool down our temperature.